Hello students, how are you? I am Parv Gupta. Welcome to the video number 10. Today we'll be learning about NodeMCU and exploring some ultrasonic and reed switch based door sensor. So let's get started with it. So as now you can see, this is our NodeMCU board that is based on the ESP12 Wi-Fi module that is made out of the ESP8266. What it does is it have an integrated programming module that is CH340. Also have a couple of components like the crystal oscillator, power regulator and a couple of resistors that make sure that you can easily program it. So here comes in hand is a ultrasonic sensor which sends a ultrasonic pulse that is very high frequency similar to bats and waits for it to receive it, and in that time duration it calculates the distance of the object that is in front of it. It is fairly accurate up to like a couple of centimeters and you can easily measure distance out of it. Let's integrate both NodeMCU and the ultrasonic sensor and see how can we get the data of distance with the help of both of these things. So let's get started with it. As you can see here in the wiring diagram, we need to connect the VCC pin of the ultrasonic sensor to the VU pin, that is the USB output pin of the NodeMCU, the ground pin to the ground pin, the echo pin to the D6 and the trigger pin to the D5 pin of our NodeMCU board. Now once you have connected all the pins, we can just plug in our USB cable and try to power everything on. Now let us move on to the code, that is the Arduino code we are using in order to program our NodeMCU. So as you can see, we have got our very simple code. Here in the line number 1, 2 and 3, we have defined the integer trigger pin, the echo pin that is pin number 14 and 12 that is D5 and the D6, and then we have declared the long, that means it is a type of a long integer, so that's duration and centimeter. So now we move on to the void setup where we begin the serial port and also we define the pin modes to be output and input. For example, the trigger pins means we will be sending a pulse out of it and the echo pins that will be receiving the pulse. Now moving ahead onto the void loop part, we can see that we trigger the trigger pin low and high after a delay of microseconds 5. So and wait for the trigger pin again after 10 milliseconds, and we wait for the pin that is the echo pin as an input. So we measure the duration in pulse that is received between the sending and the receiving part from the echo pin. So that duration is noted down and we can calculate from the duration the distance in centimeter. Here in line number 26, we are using a multiplication factor of 0.0160. So you can change it according to your requirements and according to the calibration factor what you feel is correct according to your readings. Once calibrated, you can use it n number of times. So this is all about code. Let's try to upload the code, and as you can see, when I've placed the object at a distance of 36 centimeters, it is exactly reading 36 centimeter. The readings can be off by a couple of centimeters, like if it's 36, it could be 35 to 37, not much more than that. And now let's try to bring the object closer to the sensor and see what does the reading change. As you can see, we are correctly getting the 20 centimeter reading here. This sensor can theoretically measure a distance of up to 250 centimeters. So now let's move ahead to the door sensor. So this is a door sensor that is based off a reed switch. A reed switch is, think of it as a magnetic switch. When a magnet is brought near it, the switch closes and the contacts become conducting in. This is how a reed switch is, and when a magnet is brought near it, then the contacts come in contact of each other and start conducting. So let's get ahead and let's hook up a buzzer and a reed switch in order to get the sensor data from the reed switch. Whenever the door is opened or whenever the magnet is not near to the switch, we will sound this buzzer and we can know whenever the opening of the door. So let's try to demonstrate the same thing. So as you can see, we have hooked up the wires. The positive wire from the buzzer goes to the D1, the negative wire goes to the ground. There is no positive and negative in the reed switch sensor, so you can place however you like. So one wire goes to the 3-volt pin and another wire goes to the D5 pin. So once we have hooked up all our wires, as we can see, let's try to test the same thing. Now we can also place it on a box or some kind of drawer, whatever you like, and don't want anyone to open it, or even your door. So if anyone opens it, the alarm will beep. Thank you students, this was it for this video number 10. Hope you liked the video. We'll meet next time with another video.